This is the second part of planes in 3 space. We're going to look at the vector equation of a plane, and then actually convert vector equation into the scalar equation that we talked about in our first part. The vector equation is represented by the vector r naught equals r naught plus t a plus sb. What this means is r naught is any point on the plane. A and b are 2 non-parallel direction vectors. To determine where the plane is in 3 space, you need 2 vectors for that direction. They need to be non-parallel. If they're parallel, then it only determines one side of that plane, and that isn't good enough. So if we have 2 non-parallel direction vectors, then we can determine the equation of a plane. T and S are both parameters. So much like the vector equation of a line, this just has a third component with a second parameter and a second direction vector. Let's look at the example. Find the equation of a plane that contains the points 4, 4, 0, 2, 3, negative 1, and 4, negative 1, 2. To do this, let's label our points. Go P1, P2, P3. We need a point on the plane and 2 non-parallel direction vectors. We can calculate vectors between these points to get those direction vectors. Let's do A equals P1 to P2, B equals P1 to P3. This would mean that for A, we're going to have P1, so 4, 4, 0 spanning to 2, 3, negative 1, and B is 4, 4, 0 to 4, negative 1, 2. This will be 2 minus 4, 3 minus 4, and negative 1 minus 0, giving us negative 2, negative 1, negative 1. And 4 minus 4, negative 1 minus 4, and 2 minus 0, giving us 0, negative 5, 2. Those are our 2 direction vectors. We can choose any one of these points, and we have our vector equation of a plane. I'll write this here. I'm going to choose P1 as our point. And there's our vector equation of a plane. So to change this vector equation into the scalar equation, we find the cross product of the 2 direction vectors. This is A cross B. Okay. We're going to get that cross product, and we should have negative 2 minus 5, so negative 7. Negative 4 minus 0, but the negative value, so 4. And 10 minus 0, so negative 7, 4, 10. That's our normal vector, meaning this can be plugged into our equation negative 7x plus 4y plus 10z equals d. We can plug any point into that equation. I'll choose P1 again. Negative 7 times 4 plus 4 times 4 plus 10 times 0 equals d. Negative 7 times 4 is negative 28 plus 16 equals d. So d equals negative 12. Therefore, our scalar equation of this same plane will be negative 7x plus 4y plus 10z equals negative 12. And that's the second part of planes in 3 space.